All right, today is the 25th, huh? 10/25. Okay, now before we even start, we got to remember that logs are exponents. Okay, logs are exponents. Okay, just remember that logarithms are exponents. In fact, we know it. It says log of base if the answer is equal to an exponent. Okay, logarithms are exponents, so they have to follow the same rules as exponents. Okay, so if I had, for instance, x squared times x cubed, when I multiply two bases, I add exponents, right? Right? Now, as far as a log rules go, this is what we really want. I'm putting this down so you'll understand the rule. If I have log of some base of two things, right? Of say, let's say an x times a y, okay? Logarithms are exponents. What we can do is rewrite this. We're going to, in a sense, take it apart. We're going to rewrite this as log base b of x plus log base b of y. Okay, this is our rule. This is our rule. So when we multiply with logarithms, we can break this apart as two separate logs. Now this isn't going to help you much yet, but when you get to calculus, this rule is really going to be helpful in calculus, all right? Because you're going to get some problem in calculus. It's really pretty messy. You're going to be able to use logarithms to break it up into simpler parts. Maybe more parts, but smaller parts, okay? So when you get to calculus, you're going to be glad you learned this, okay? Now, we also know, as a rule, if we have, say, x to the 7th over x to the 5th, that we subtract exponents, right? So, if that's true, if we have a log of some base, b, we'll just say b, of x over y, we can rewrite that as log base b of x minus log base b of y. Now, one thing to note while you're writing this down is the bases always have to be the same. Okay? So here's our rules. I'm going to highlight these first two rules because there's more rules coming. Here's our first two general rules. Again, you might say, where am I ever going to use this? What's this for? If you take calculus, these log rules are quite a bit easier because they take something that can be kind of confusing, a division problem, and changes into two little subtraction problems. Okay? It will make your calculus easier. Okay? Now, if I had x squared to the 4th power, we would multiply exponents, right? We would multiply exponents. And we'd get an x to the 8th, right? We know that. But logarithms are exponents. So if we had, for instance, a log of some base of something, and that's to a power, like an exponent, to a power. What we're going to do is bring this down. We're going to take the exponent down. We're going to rewrite as p times log base 2 base b of x. So I have an exponent times an exponent. I really did. This is an exponent. I know it doesn't look like an exponent, but logs are exponents. I really have an exponent times an exponent, which is what I would have done up here, right? They follow the log rules, okay? Now, highlight that. Now, grab your journals, okay? Grab your journals. Hang on to this, and let's see what your journal says, okay? So, on page 155, okay, page 155, we go to our journals, and here's our properties, okay? Here's our first one. It's exactly what we said, okay? We said if we've got log of the base b of m and n together, right? We can break it up into two logs. If it's multiply, we make it add. If it's multiply, we make it add. Log of base b of m plus log of base b of n, okay? Here it is right here. If we divide, we can rewrite it as a subtraction, okay? And if we take a log to an exponent, we bring down the exponent and we multiply, okay? So those are our rules. Now, let's do some math with those rules. Okay, I'll let you catch up. I need a pen. Here's a pen. Okay, turn the page. All right, so let's go to the next page, right? Let's go to page 156, okay? So first of all, 156, and I want to do, first, I want to do 9. We're going to come back to number 1. Let's do number 9 first, okay? Let's go back to 9. I'm going to come back to 1, okay? Okay, so on number 9, what I want to do is this. I'm going to just do the log rule, okay? So log rule, let's see. All right, where's my notes? Where's my notes? Here I have my notes. So I'm going to take these two logs, I'm going to bring them back together. I'm going to take these two logs, I'm going to bring them back together. I'm going to use this rule right here. So it says plus, right? I'm going to rewrite this. It's this easy. Log base 2 of 3 times 8. Now it doesn't ask me to solve it, just condense it. Well, I've condensed it, right? Well, I may as well go 3 times 8. That's easy. That's 24, right? So log base 2 of 24. Okay, it said plus, so it said condense it, bring it together. So it says plus, we bring it together as times. Okay? Okay, let's look.
You're not going to do it anymore than that, like equal.
Not yet. I got to show you one more trick. I'm going to show later. Little steps, okay? Okay. Now 10. Well, 10's got a trick we got to be careful with. Okay, before I do 10, let me highlight it. Okay, highlight it. Okay. So this 2, everybody looking? Check it out. This 2 right here. You looking? Everybody looking? See this 2 right here? It was a number that could have been an exponent, right? A number out in front of a log could have been an exponent. So let's rewrite it as an exponent. So what I'm going to do is bring the 2 back up and in. So I'm going to rewrite this. So I'm going to write it as log base 5 of 4 minus log base 5 of 5 squared. So I brought the 2, put it right there, okay? So I'm following this rule here. If it was a number in front of a log, it was an exponent, so just put it back in, okay? Now, subtract, right? What does subtract mean? Well, it looks like if we had a subtraction between the two, we can make it a divide problem, right? So I'm going to go, all right, I'm going to go log base 5 of 4 over 5 squared, which is 25. Yes, totally right.
Would you just square root that?
No, we don't want to do that.
But 4 is perfect square as well.
But there's no reason to square root it, is there?
But it would simplify it.
There's no reason to square root. There's no x squared problem in there. So let's do it Price said though. Let's log base 5 of 4 over 25, right? No, don't square. No. Just 4 25ths. There's no square root to take. Okay. All right. All right. Let's go to 11. Okay. Okay. First of all, 11. This 3 is on the outside. It was an exponent. Let's bring it back in. Okay. It was an exponent. Let's bring it back in. So I'm going to have a ln of 6x cubed plus ln 4y, okay? So if I've got a number sitting out in front, it was an exponent, so bring it back in, okay? Now, what am I going to do? Well, I'm going to rewrite this as ln of, plus. What am I going to do with plus? Plus, let's see what my rules say. Well, my rule says if I add them, it came from a times, right? My rule says if I'm adding them, I can put them back times. Okay, so let's rewrite this as a 6x cubed, or how about a 216 x cubed times a 4y. Yeah, where'd the 216 come from? Where the heck?
24 times.
Where did the 216 come from?
Oh, it's cubed. I thought you said squared.
6 times 6 is times 6. Okay, now, am I done? Well, I don't know. What's 216 times 4? I don't know. So it's 216 times 4, 864. So how about ln of 864 x cubed y, okay? All right, now, let's do one more of these, okay? How about the hard one? How about 13? Oh, yeah, let's do 13. Let's do the hard one, okay? All right, I see lots and lots of things. First of all, I'm going to do 2 things. This was an exponent. I'm going to bring it back up, okay? All right, that. And I'm going to rewrite it because I don't like this. This is like a subtract, right? So I'm going to do this. I'm going to rewrite this as, first of all, log base 6 of 3x squared. I'm going to do that first, okay?
Negative, right?
Not yet. Not yet. Then minus log base 6 of 6 minus log base 6 of 2y. Okay? Here's the hard one, right? So I changed the order because these are like subtract. These are like subtract, right? So I changed the order. It's going to make it easier for you, okay? So let's see what I have. Subtract means divide, right? Subtract means divide. Subtract means divide. So let's go log base 6 of 9x squared over divided by, because I'm subtracting, so when I subtract, divided by 6 and 2y. So I'm divided by both of them, okay? So I put these two on the bottom, because subtract in my rule means divide, right?
And you're just going to leave it like that, or you're going to simplify it?
Let's simplify it. 9/12, what's 9/12 reduced to? 3/4? Yeah. So let's go log base 6 of, this is 9/12, you guys, 9/12 reduces to 3/4, 3x squared over 4y, okay?
Cool.
Now, if we can condense it, then we can spread it out. Okay, if we can condense it. So let's make 5, 6, 7, and 8 look like this. Okay, let's make 5, 6, 7, 8 look like these. Okay, so let's see what we got. Okay, now, you don't see it, but it's there. There's a times sign between the 10 and the x.
Yeah.
You guys agree? So if they're being multiplied, I'm going to spread it out and make it plus. So I'm just going to go, okay, I can do this. It's an easy one. I'm going to go log of 10 plus log of x. Okay, there's a times sign in there that's invisible, right? How about 6? There's a times sign there, right? Invisible times sign? There is. There really is an invisible times sign there. You guys see the invisible times sign? No, you don't, because it's invisible, but you know it's there, right? So how about ln of 2 plus ln of x to the 6th? Because my little invisible times sign, I got a plus. Now, oh, I got one more
Is
thing.
that ln2 base 2 or ln2?
It's ln of 2, right? Because it's that 2 right there, okay? Now, one more thing. Oh, hey, if there's an exponent, we can float the exponent down. If there's an exponent, we can float the exponent down. So I'm going to take this 6 and go a 6 ln, oops, ln, that looks like an H, ln of x. So I got ln of 2 plus 6 ln of x, okay? This will help you once you guys get to calculus, if you ever get there. Okay, now let's do 7 and 8, and then I'll move on to something totally different, huh? Well, it's not really totally something different. It's the same stuff. Okay. All right. So I see a division, which means I'm going to have a subtract. Okay. You guys see the division? So I'm going to go, okay, log base 3 of x to the 4th minus. You guys okay with the minus?
Why is tomorrow's assignment already on?
Because I'm going to be in a conference tomorrow of 3y cubed. Okay. So all I did was this. Here's my subtract right there. Okay. Now there's more to do. There's more to do. There's an invisible times sign here, isn't there? You guys see the invisible times sign? So I'm gonna go. Okay. I'm gonna go. All right.
I do see it.
Log base 3 of x to the 4th minus log base 3 of 3 plus log base 3 of y cubed. Okay, all I did, invisible times sign, I made a plus. Invisible times sign, I made a plus. Now there's one more thing, I can float the exponents down, okay? One more thing, I'm going to float the exponents down. So the 4 comes down. 4 log base 3 of x minus 3 log 3 of 3 plus float the exponent down. 3 log base 3 of y, okay? Now, why do we even learn these rules? Well, for us, it's gonna be handy, okay? All right,
The
so,
says it's gonna help us in calculus, but what's calculus gonna help us? In Calc 2? Yes.
yeah, probably, yeah. Depends on what you wanna be when you grow up.
Calc 7.
4.
Depends on what you wanna be when you
And
grow up, okay?
differential equations, then
Okay.
when you're algebra, then-
Can I say this?
The secret.
My oldest son, guys, my oldest son uses calculus every day. People do. Do you know how much money he makes?
No.
A lot. A lot that he gets a bonus. His bonus was $50,000 last year, and they just gave another $50,000 bonus. That's his bonus. So how much money does he make if he gets a bonus of $50,000? Some people, that's all they make all year, right? Wow, isn't that great? But he does calculus. Oh man.
What is
Okay.
his job?
Amazon.
He works for Amazon. He has a PhD in economics, so he's an economist. He helps them with forecasting. So his busiest time of the year is right now. You know why right now?
They're ordering
Christmas is coming up. Yep. Okay, 14.
Thanksgiving shopping.
Okay, guys ready? I'm gonna finish up. I'm gonna do 14. Actually, let's do 1 and then we'll do 14. Okay, let's do 1. Okay. Now,
First problem on the homework.
I'm almost done. I got 2 problems I'm gonna do.
A
Okay.
bit different. Yeah, 1. Cool. That's what it's
Yeah. Now here's the problem. Your calculator. Ever listening? Seriously, listen for the next couple of minutes.
Ow.
Base 2. It's not on this.
No.
Base 10 is, and base E is. Base 10,
Do they not have...
base
Can
E.
you not change it in math?
So here's what we're going to do. We're going to go like this. Set it equal to x. Okay? We're going to change this to exponential form. Exponential form, okay? So remember, we're going to go from log form to exponential form, okay? So I'm going to go, right? I'm going to go 2 to the x equals 60, right? You with me there?
Yeah.
Now, we learned this rule. We learned this rule that if we were to take the log of it, it floats the exponent down. That's why we learn logs. If I took the log of that, it's going to float the x down. So I'm going to do this. I am going to take the log of both sides. I'm going to say, okay, log of 2 to the x, and I'm going to take the log of this side. You can just do that. What you do to one side, do the other side, okay? Now, log 2 is a number in my calculator. Log 60. Now, you notice what I did. I didn't give it a base, right? You know why I left it just regular log?
10.
Because I can use my calculator, right? So leave it as regular log because I can use my calculator. Now, the x floats down. So we float down the exponent. That's why we do the rule. So the x comes down, and we get x times the log of 2 equals the log of 60. Okay? Now, a little side note. I'll do right here. Okay, a little side note. If you had 3x equals 12, you would divide by 3, right? You guys agree? Divide by 3, divide by 3. Same thing. This is just a number. It's just a number on my calculator, isn't it? So let's divide by log 2. Divide by log 2 and use our calculator. Now you got to be a little careful when you use your calculator because you got to close parentheses. I'll say it again. You're going to close parentheses. I'll say it again. We're going to close parentheses. Watch. We're going to go log 60. We're going to close parentheses, right?
Would it just be x equals...
Divided by log 2, and my answer is about 5.9.
That's not what I thought.
That's what I got.
Why can't it just be log 30?
It isn't,
Why can't it be?
because log 60 is not, try log 60 is this number, okay?
Okay.
Log 2 is this number. If I divide those two,
Okay.
is that enough answer?
It shouldn't be, but it is.
Okay, good. All right, so what did I get originally? About 5.9, okay? All right, last problem. Seriously, let's go back. Let's go all the way to 14.
What about the x on the other side?
Well, that's x equals, right?
Okay, so x equals 5.9?
Right,
Okay.
right. Okay, let's go to 14. Okay, base 3. Bummer, right? Bummer. Let's change it to base 10 so we can use our calculator, okay? So how do we change it to base 10? Set it equal to x, right? Change it from log form to exponential form. Price.
So on number 1 it said in exercise 1 through 4 use log 2 to the 5th equals 2.332 and log
I wouldn't do that.
Equals 3.585.
Nope, nope, there's an easier way to do it.
Because it says that on the homework too.
Right, just do it the way I told you. It's much easier. Okay.
Okay.
Okay, so 3 to the x equals 17, okay? Set equal to x and change it. 3 to the x equals 17. I'm just doing this, right? 3 to the x equals, okay, now, listen. Get rid of the x. Bring the x down. Float the x down. How do you do it? Take the log. The only way you can get the exponent down, float it down, is by doing a log of it. So we go log of 3 to the x equals log of 17. And then what happens is the x floats down. So then you're going to have x is equal to log 17 divided by log 3. Now, what is that in my calculator? Log 17 divided by log 3. 2.58. Now, okay, you guys are smart. Price, if I wanted to shortcut this, guess what I'd write? To shortcut this, you want the answer? It is going to be log of 294 divided by log of 9. Use your calculator. You want to shortcut this? How about log of 4/7 divided by log of 9? You want to shortcut it, right? Shortcut it. It is log of 1/10 divided by log of 6. Use your calculator. Isn't that slick?
Isn't it 4 9s divided by 6?
Yes, thank you. So,
Wait, wouldn't it 16 be log 7?
yes, see what I did, Emma? I put the numbers in the wrong place. Yeah, I did. So what am I doing? I'm just taking the log of the answer number, and divide it by the log of the base to get the answer. That's all I'm doing. So the base is that number there. That's the base, or that's the base. So you're taking the log of the big number divided by the log of the base, and you get the answer. But then you can use your calculator, because when you see log, it's calculated log,
That's
right?
really cool.
Isn't that nice? Yeah. Okay, so that's all I got for today.